So let's put this into practice. Let's do a sample problem together. Solving for the population standard deviation. Okay? So let's say that we have several numbers, and let's call these numbers x to the ith, right? So we got 5, 10, 7, 8, 8, and 5, right? And let's put our let's just put our steps in order from the formula for. So the formula says that standard deviation of a population is equal to the square root of x of ith minus the population mean squared divided by n, and we got to remember to put our sigma in there, which means that we got to add all of our numerator up, right? So let's go with step number 1, right? Step number 1 is that we must determine the population mean. So remember what we'll do. We'll add all of our observations up, and that'll give us 43. And remember that the formula for mean is simply n divided by frequency. And in this case, it's 43. And there are 1, 2, 3, 4, 5, 6 observations. That gives us a mu of 7.16, right? So that's step number 1, right? So let's go on to step number 2 in the formula, right? Step number 2 says that we will subtract x of ith from the population mean, right? So in this particular case, it's going to be our population mean is 7.16. So we're just going to subtract 7.16 from each one of these, right? 7.16 minus 7.16 minus 7.16 minus 7.16 minus 7.16 minus 7.16, right? And what we'll get for each one of these is, our first one is negative 2.16. Remember, it's a smaller positive number minus a larger negative number, so it gives us a negative number. And we'll go 2.84, 0.16, 0.84, 0.84, and negative 2.16, right? So we've done everything that it says there for subtracting our x of ith minus our population mean. So we'll move on to step number 3. Step number 3 in the formula says x of ith minus mu squared. So basically what that means is that we have to square each one of these, right? And if we're squaring each one of these, that basically means that we are just multiplying it by itself. So for our first one is negative 2.16 times negative 2.16, or you can use the square function on your calculator. Remember basic math rules. If we multiply a negative by a negative, we get a positive. So if we square something, we can never have a negative outcome. So negative 2.16 times negative 2.16 equals positive 4.67. We're just going down the line. 2.84 times 2.84 is 8.0 7. 16 is 0.03. 0.84 is 0.79. 71, I'm sorry. 0.71. And 4.67. Right? So step number 3 in the formula has this uppercase sigma, and that looks like this, right? And the uppercase sigma means that we have to sum what we have, right? So let's just move on to step number 4. Step number 4 looks like the sigma here, x of ith minus mu squared, right? So that means that we have to add everything that we got here, right? So let's put a little plus sign here. So that means that we add all of these up, right? And once we add them up, we get 18.86, right? So let's just put that there, 18.86, right? So now we're moving on to step number 5. And step number 5 was that we had to divide what we got so far by n. In this particular case, n means the number of observations. So n for us is 6, right? So that means that we divide this by 6, and that'll give us 3.143, right? We're not done because we have one more step, and the last step was to take the take the square root of this, right? But what we have without the square root is called the variance, right? Okay. So this is the variance, but we have an additional step. So step number 6 calls for us to take the square root. And the square root, so our entire formula looks like this, right? X of ith minus u squared over n, right? So we got everything in the square root, right? And we know that everything in the square root is 3.143, right? So we'll just use the square root function on our calculators, and we will come out with a population standard deviation of 1.77. And I hope my scribble wasn't so bad and everybody can understand, but if you just follow along with it on a scratch piece of paper, you should be able to do it without a problem.